Hey, happy April 1st. This is my only joke is my silly glasses that I got at a flea market last September. But hey, everybody, welcome to Guru session number 5. I know I have to actually switch to the real glasses so I can see what I'm doing. And if you haven't seen it, look in the chat or scroll back in the chat. There are two movie files that are not in the download and they won't be found when you open the Isadora file. That's because they're not my movies and I had to give links to those so that you can go and download them, yeah? So I'm just gonna vamp here for a minute while some of you go and get those files, yeah? Look back in the chat if you need to look back in the chat. All right, I actually need to get those files, so let's do that. So just giving you all a minute to scroll back in the chat and make sure that you have the files that you need to be able to do today's session. And I'm doing that too with you because I figure if you do it and I do it, then we've all taken the same amount of time to do it. So getting the movies now. Someone was asking about resolution. I think probably the 1080p is okay if you've got a good machine, but if you want to be super safe, get the 720p version and use that instead. Okay? All right. So now I can bring these over here, double click, and we're going to be ready to go. All right, I'm going to check the chat here to see how everybody did getting those files. Let's see here. All right. Okay, I see someone saying something about missing the target 3ds file. Target. They should be there. I'm pretty sure they're in that folder, so if it's not finding it, I'm not quite sure why. Lucas, maybe you can check in on that. All right, I think that we are ready to go. Let me see if I'm ready to go one more time. I'm gonna go here, and I'm going to open the file. And so it's going to ask me where those two files are. Those are the ones I downloaded from Vimeo. So I'm going to do this one and this one. And now I've got my files and everything is here. All right, so thanks for your patience. If you're not finding the files, ask Lucas on the chat. He'll try to help you out. But also, the last session, there was so much chat. It was really, really tricky for me to see what's going on. So I'm glad you're all saying hello. That's actually part of why we're here. Did everyone see me in my glasses? Yes, it's April 1st. Okay. So, but once you're done saying hello, try and really limit it to the questions you really need to have answered because it's a little tricky for me when it all scrolls by because there's so much dialogue going on in the chat. Okay? All right, so today we're looking at 3D, yeah? This is a feature in Isadora that, I don't know, some people are into it and really understand it and not, some other people don't use it so much. So we're just gonna look at some of these topics and bring you to an understanding, and I'm gonna really start in a simple way, and then we're gonna build up from there. What you're gonna see in this file is I've got some empty scenes, and then the scene after it, it says, like here in the second scene, square, circle, triangle, finished. So I sort of am going to build these in front of you so that we can go through them together slowly. But then you'll have the finished version so that you can look at kind of where I got to as I was preparing the class today, yeah? But let's start with the simplest kind of situation. I'm going to add a 3D projector. So I double click in the scene editor, type 3D proj, hit return, and there we go. and let's go to the output menu and say, I'm going to say 4-stage preview because I've got a second display. And there you see this white rectangle. So that is a projection surface that exists in 3D. And the thing that you need to understand about the 3D world versus the 2D world is in Isadora, all the 2D stuff, like pictures and images and movies, that's rendered first. And then the next step is that any 3D things that are happening are rendered next. Yeah? So just for an example, look what happens if I take this picture player, if I drag this image into the scene editor. You'll see that that background appears, but it's behind that white square. And there's no way to bring those together, because the thing that you sort of need to understand about this is that the 3D world and the 2D world, which probably a lot of you work. Oh, yes. Thank you, Fubi. Sorry, everyone. Still learning how to be good at this. Thank you for your patience. Here we go. Sorry, everyone. Let's just step back through. I'll just step back and do that again. Sorry about that. Sorry. Okay. So here we go. Gonna start over. 3D projector, 3D proj, and now you see the white square. And what I was explaining about was these two separate spaces, the 2D space and the 3D space. If I bring this Isadora backdrop.png in, you'll see that it appears and it's behind the square. And in fact, you can't really bring those two worlds together. They are just totally separate because the 3D world allows this actual 3D movement. And in the 2D world, you've only got that one dimension, or the single, the X and Y, but not Z. Yeah? So I'm going to delete that picture player, and I'm going to drag out. I didn't put in any other movies. If you have a nicer movie that you want to bring into this file, please do. But I'm going to use these movies that you downloaded. So I just drag that in. You can hear the sound of the movie. I'm going to set the volume to 0 because we don't want to hear that right now. And I'm actually going to delete the projector because we're not using the normal projector. We're going to use this 3D projector, right? So if I go over here and I connect the video output of the movie player into the video input of the projector, you see this scene of this waterfall. Yeah, this is actually a 360-degree movie, and I hope it's the right one. Hold on, I need to take a look. Yes, it's the right one. So now it's being projected on this projector, but the difference is that this one can actually move in 3 dimensions. So let's start by simply looking at the rotation inputs, right? So if I do an X rotation, X is this way, right? So we're going to rotate around that axis, the one that goes this way. Okay, if I set that back to 0, if I do the Y rotation, it rotates around that axis. And the Z rotation is the one that goes in towards your eye there, right? So those are the 3 rotations we can do, and then so you can take this image and spin it around and do things like that, excuse me. But you also have translations. So translation is just like moving, right? So X translation moves this way, Y translation moves this way, and Z translation moves this way, right? So yeah. So it sort of looks like zoom, but it's actually not a zoom. And here's what I mean by that. If we go and I'm going to make another movie player, set the volume to 0, and I'm going to play this other movie, which is of a seashore, and I'll add another 3D projector. And already, you saw briefly there, actually, let me disconnect that again. So you see the white square. It's there, but it's behind this one. But let's connect this, yeah? And now I'm going to do the Z translate. And see what happens? One of them is in front, and one of them is behind, yeah? And we're seeing that overlap. I mean, we're seeing through it because the blend mode is additive. This is similar to the way that the normal projector works. So to clarify that, let's set the blend mode to transparent. So you click on the left of blend, type TR, and hit return. And now you can see what happens. And to make that even more clear, leave it so that both of these are set to minus 2.5 in the Z translate. But on one of them, you want to set the X rotation on the left one to minus 45. Sorry, let's not do that. Take that back. The Y rotation to minus 45. And on the other one, set the Y rotation to 45. And now you can see that these are actually intersecting each other, and that's why they're different than this 2D world, because they're looking at each other, and things that are closer to you will obscure things that are further away. And you can see that even more clearly. See what happens if I sit here and I move this in and out? And to make that even more clear, go to the zoom of the left one and set it to 80 so that you can see that it's a little bit smaller, and you can see where they're intersecting, right? So as this one moves back in space, the other one, which is sitting here at a 45-degree angle, I'm moving this back in space, and it gets hidden, right? So that's the big difference, and the thing to understand about working with 3D is that you have this third dimension, and that in general, things are going to block each other as they move forward and backward, because remember, the whole reason that these features exist, the reason we have graphics cards is really so that people can play games. That's really what they were designed for, not for doing what we do with it, right? But so this kind of thing, when you're trying to render a realistic scene of what's going on, that's what you would like to have, right? So, and you can also play around with these rotations. You can see that how if I rotate that Z rotation, you can see how it really slices into each other, right? So that's the one thing that you have to think about with 3D, is that these things are going to overlap, going to obscure, and that's what the power of it is. That's why we would want to use it, and that's some of the things I'm going to get into today. But the other thing to point out here is that all of these rotations and translations are local to this object. In this case, the object, and it is kind of a 3D object, is just a rectangle. And we're rotating it around its center and translating it in the space, right? So we move this left and right. So for instance, one thing that we could do, let's just, so that we're in the same place, everybody select their 3D projectors and say reset to default values. Reset to default values, sorry. So select your 3D projector, choose reset to default values so that we're all in the same place again, because I want to do one other thing here. So for instance, let's say we wanted to make it look like we were looking into the corner of a wall, right? So to do that, we will set the Y rotation of one of these to minus 45 to turn it that way. And we'll set the other one, the Y rotation, to 45, right? And now what we need to do is we just need to translate it. So we're going to go in the X translate, and I suggest that you hold down the Shift key so you have a very fine increment. So Shift click in X translate and just shift that over a little bit. Yeah, 44 I did. And then same thing on the other projector, but shift it the other way. And if you just tweak that a little bit, you'll end up here looking as if you're looking into the corner of a room, right? So we're kind of building, using the 3D projector, almost a 3D room, right? A 3D space. But the thing to remember about this is that there's an imaginary camera. Your eye is the camera, and we're looking at this entire scene. So let's see if we can move that camera. So I'm going to have you add a 3D stage orientation. I debate about changing this to 3D camera because in fact that's what it is, but that's what it was called forever and ever. So the 3D stage orientation is the thing that changes the viewpoint of that camera, right? So the first thing you can try is to click in the Z translate and just drag that down, and you'll see that they go off into the distance. That's because the minus Z, the camera's going like this, backwards, right? So just like in the real world, if you back up from something, the scene widens out, and the things that are further away now look smaller, yeah? And if we go positive in the Z-translate, we can go all the way to where the camera goes past, it goes past the two screens, and it's beyond them now, right? So this is how you can change the viewpoint of the scene. And the thing that is important to understand about this is kind of a global viewpoint, right? So we've arranged those two things to be like this at an angle, or like this for you, right? And now we're just taking the camera and moving around and determining how we're looking at that stuff. So one thing you can try is, for instance, the X rotation, right? So because they're a little bit off in the distance and we're rotating kind of where your eye is, you see it goes like this, or the same thing with the Y rotation. So we can rotate that entire scene, yeah, with those rotation commands, or move the entire scene using the translate. See here, it looks like we're driving by it in a car, right? Okay? So that's the 3D projector and just some basic manipulations, but this idea that you have individual objects that you position and place in relation to each other, and then you use the 3D stage orientation to change the overall view and how we see all of those grouped objects, that's a really important concept to understand because we're going to make use of that today. Yeah? Okay? So I'm going to check in a moment for any questions as we go along. I just want to see if anything's coming up for people. So let me click here on this. Yeah, and yeah. So, all right. So no questions so far, I don't think, or I'll just keep looking, but let's go back. So let's get into now that oh yeah, one other really important thing. So, you know, these 3D projectors, there's kind of some extraneous stuff on there that, you know, like there was this whole thing of the image offset, XYZ. There's some things for doing stuff. This is kind of from the ancient days of Isadora. I think really if you're going to work with 3D, I have a better suggestion is using the normal projector. And everybody, I hope everybody here by now knows, if you click on that eye, you know, look at the tooltip. To change the visibility of inputs or outputs, double click this icon. In the help, it always says, you know, whenever you click on an actor or in an actor that has an eye, it says at the top, this actor has hidden properties. It's telling you over there to remind you. And so if we double click that eye, there's a whole set. Those same things that you see in the 3D projector are all there in the normal projector. If you turn on this 3D enable, you need that to move it to 3D mode. And then you have render back, depth test, translate, rotate, like this. And you say, okay, now you see it has the same inputs as the 3D projector. And in the end, it was my intention that this actor would supersede the 3D projectors that we've had from the past, but that eye icon, not everyone realizes it, that you can open the actor up and change this. So you'll see that if I turn on 3D enable, all those same inputs that we have on the 3D projector are there. Yeah? In the end, we're going to keep the 3D projector because there's loads of patches that use it, so you don't have to worry about it going away. But it's actually a little more clean to work with the normal projector because you don't have some of these other inputs like the image count, lifespan. Those are kind of not so powerful particle systems, right? Those extra features. Yeah? Okay, so that's the 3D projection. How to reset the camera view to the default? I think the easiest thing to do is to click on the 3D stage orientation and say reset to default values, right? So everything becomes 0, but you can see here that the rotations and the translates for the 3D stage orientation are 3D are all 0. So you can also just go 0, 0, 0, 0, 0. Yeah. Can we set the rotation point for the 3D objects? No, it's always rotating around its center. That's something that we can talk about adding. It really wouldn't be that difficult to add, but it's going to be one of those things where it makes the actor bigger. We probably want to put the eye icon on it. But the answer is right now, no. You're always in the side of the 3D projector. It's rotating around its center. Or in a moment, you're going to see with the 3D player, it's the same thing. It's rotating around its center. And then I see a question. And by the way, if you're typing questions, it's super helpful if you put the word question in capital letters because it helps me pick it out of the chat. This XYZ in the 3D projector, there's a question, what is the difference between this XYZ down here and the X translate, Y translate? This has to do with the feature of being able to do these little very simple particle systems. Honestly, it's been so long since I've used it, since the 3D particle actor is much better. I may not remember, but I'm going to try. I'm going to set the Z offset to 5 and leave it set to the middle and set the image count to 10. Yeah, so I set the image Z offset to 5. I set the number of images, that's kind of like the number of particles in the 3D particles. And then if I hit add image, you see them fly out. Now let's see. Yeah, I honestly don't know because it's been so long since I've actually used those inputs. Let's see what it says over here. Okay, it says the Z coordinate of the image. So I guess, let's find out if this is true. Sorry everyone, it's really been ages since I've tried this. If I do the rotation, does it still? Aha. Okay, so bone map, to go back to your question, can we rotate something around a point that is not the center? The answer is yes for the 3D projector, not for the 3D player. So what I did was I offset the center point of this image by some amount. And you'll notice when I do the Y rotation, it's no longer rotating on its center, it's rotating around 0. So here's 0, and I push the image back, and now when I do the rotation, it's going like this around that center point, not around its center, yeah? So I actually misstated myself, so you have to forgive me for that. I just haven't used those inputs in so long that I didn't actually remember, to be perfectly honest, okay? Let's see. And how does the 3D mode affect IZZY-map in the normal projector? Good question. I think it will, what it should do, I actually don't know the answer. I guess we'll have to try that. So I'm going to answer that question by just quickly doing this. Set the volume to 0. Just quickly whip this up. So there we've got a movie, double click. I'm going to create a projection mapping. I will just do something super simple. I'll make a triangle. And a circle. Okay, so there's that. Okay, so I just made this little simple projection, simple thing, right? So now I close this. I turn the 3D mode on. It basically just takes the 2D image and allows you to do everything that you were doing before. So the rotations work. So it takes the 3D, the image that's coming out of IZZY-map, which is in the end a 2D image, and now you can spin it and rotate it and do stuff like that. That's what happens with IZZY-map, yeah? So, all right. Let's continue. So this is just our first beginning thing with the 3D projector, yeah? And I wasn't going to focus so much on those actors, but the other important thing to realize, everything that starts with the two letters 3D has something to do with rendering to the 3D space, right? That's your clue that that actor is going to do something in the 3D space as opposed to the normal projector and things like that, right? So I actually am going to rename this. I'll re-upload this after I'm done. I'll just call this scene 3D projector. And I'll call this 3D features with IZZY-map so that you remember what that is. Okay? And now I'm going to just go here and make a new file because I'm going to build up this next scene where we use the 3D player. Yeah? All right. Um, yes, would be happy to do a guru session on mapping. I might not be the best one to do it though. We might get one of the other guys on the team to do that. But the answer is yes, we should do that. There's lots. This is going to go on. As long as we're in lockdown, folks, we're going to be doing sessions. So that's something that we can definitely plan on. Okay. Um, so, all right. I want to now work with the 3D player. So some of the things that we just learned are going to totally apply here, but now I want to do it with these 3D players. And let's talk a little bit about 3D models because that's what we're about to work with. Everything I'm going to work with from this point forward is in the 3D models list here in the media view. Now, Isadora is a little bit limited right now in that it only imports the 3ds model format. And there's a lot of other formats out there, and a lot of people have asked us to upgrade that. That is absolutely on our radar, and maybe by the time, if you're watching this in a couple of months, we will have added those extra formats. For sure, OBJ is something we want to do. For now, we're going to be working only with 3ds files, yeah? So I've prepared these, and I always throw this in at this point in the discussion about 3ds files. I love my little 3D editor. It's a Mac-only program called Cheetah 3D. I'm not going to show it here because that's a different topic, but it's the easiest, fastest, simplest way for me to deal with 3D models and objects. It's very Mac-like. I love the user interface. I know there's a lot of far more sophisticated options out there, Blender and Maya and things like that. But for a $99 program, this really does the job. So if you're curious, you can look up Cheetah 3D. I find it, especially if you're kind of new to 3D, it's something that I can really recommend. All of the models, all of the models that you're seeing here in this tutorial were prepared in Cheetah 3D, okay? So I'm gonna go here and just start by dragging this this model called 3D red square into the scene editor. And the first thing is you don't see anything. And that's always, brought this up in another tutorial, that's always the thing with 3D. The camera defaults to 0, right? It's at the center of the world. And when you bring in this object, if it was saved so that it's at the center of the world, which these objects were, you're not going to see anything because your eye is actually inside the object. To be able to see it, we need to pull the camera back, right? We need to pull our eyes back so we can see it. So here's the 3D stage orientation again. And you'll see that as soon as I pull this back, you can see this square. And it's actually not just a square, it's a cube. So if I rotate it on the y-axis, you can see that it has a shape. So everyone try that. Bring in the 3D player. So just drag red square into the scene editor, drag in a 3D stage orientation actor, and then zoom the Z-translate back a bit. Okay. So now the one thing is it's not so nice about this is that there's no shading on this yet, right? You just sort of see this blobby shape. You see that it's sort of a cube, but you can't make it out. And that's because the default for the 3D player is that the lighting is off, okay? That's the default. And if you want to have that shading from the lighting in the 3D space, you have to turn that input on. So I'm going to turn the lighting on now. And now you'll see that if I go in a little bit closer, yeah, you can see the shading there. If I rotate, I'm just clicking in the Y rotation and rotating it, and you can see that it's changing, yeah? So that's one thing, is that if you want to see the shading that's on these objects, you need to turn the lighting input on the 3D player on, yeah? And we can also control that lighting. So if I leave this at -3, and I'll do minus 45-degree rotation. Now, you may not even be able to see in your screen, I can barely see the one side because it's so dark. That's because of where the light is coming from. But we also have a way of controlling where that light is coming from, and that is the 3D light orientation. Yeah? Yes, and by the way, so I saved all of these objects so that they were the zero, the center of the world, the object was right there in the center. But if you offset the object and save it that way, when you load it in, it will be offset in the scene. So Isadora always refers to 000, and so if you save the file so that the object is sort of over here, if this is the center and it's over here, when you look at it in Isadora, it will still be over there, right? Okay? So here we have the 3D light orientation, and you can just try experimenting with the X rotation, Y rotation, and Z rotation, because you'll see that as you rotate the light through the different angles, different parts of the object become brighter and darker. In fact, at a certain point, it's going to become fully white, yeah? And the reason for that is that when the light is hitting the face of the cube directly at a perpendicular angle, it becomes fully white, right? Because it's reflecting on it perfectly. But there's some settings we want to look at here that are important. So let's say leave it set to -36. Sort of you can see the one side of the cube. So again, the Y rotation on the 3D player is -45. The Z translate on the 3D stage orientation is -3. And the Y rotation on the 3D light orientation is -36, yeah? So let's look first at this specular color, because these colors change the way you're going to see the object, yeah? So here I'm going to go in and I'm going to just click on the grayscale slider, and you can do this whatever tool you use. Actually, let's do it this way. Let's do it with Isadora. I'm just going to click on the dot to the left of specular so I get the mini palette, and I'm just going to drag this down. So it's pretty dark. You'll notice nothing changed, right? Nothing changed yet. But if you go now and you do the rotation of the light, it doesn't flash like it did before. And the reason for that is that the flash you're seeing is what's called specular color. Specular color is designed to sort of simulate a bright spot on an object. To make that super clear, I'm going to temporarily switch this to the sphere here. So I'm going to go to model number 2, the green circle. And you see right now, you don't see much of a highlight there, but watch what happens as I change that specular input. Do you see how you get that sort of extra white spot and it looks like almost like it's a shiny surface and it has a reflection? That's what the specular color does, is it gives you the impression that the object is sort of shiny and that you can really see it, yeah? The other thing to notice, which I should have had a white one maybe so you could really see this, but the color, here if I make it completely red, it's a little hard to see, but if you drag this around, that specular color can be any color you want. It doesn't have to be white. So if you want it to look like you have a bright sort of pink spotlight on whatever it is that you're illuminating, if you turn that specular color to pink and turn it up, you will see these pink reflections in the object, right? So that's the specular color, okay? And if you change the object like I did, go back to object number 1 because the next thing I want to show you is important for that. So the other color, another color down here is the ambient color. And that's the color, that's like the minimum that anything gets. Like, let's just say it's kind of true in the situation I've got right here. Again, I'm going to go back to -36 on the Y rotation. It's kind of too dark on the right side of it. I don't want it to get that dark. I know my projector doesn't have a great gamma and maybe people aren't going to see it. So I'm going to raise the ambient brightness up. And do you see what happens? That dark spot is not so dark. So you're kind of essentially reducing contrast, but you're ensuring that the dark spots in the objects are never too dark. And again, I can change that. I can make that, and you can see how I can change the color of that ambient light. So normally you would leave these things set at white, but all of them can be a color if you want to influence the color of the scene, right? So I just raised that ambient up a little bit to make it so that the dark side of the cube at this lighting angle is not so dark. And finally, the main color, the color that sort of illuminates everything, I should have maybe started with that. The most important color is the diffuse color. So this is just the overall general ambient lighting. Specular lighting is focused. It's like if you know the theater lights, the Licos, the focus lights, it is a focused light. Whereas the ambient light is more like you've got some lamps in the room and they're just lighting the world up in general, right? And so we can change that too, and you'll see that as I change the color of this, it changes the color of the object. Because it's pure red, it's a little hard to see that effect. We'll be able to see that better in a little bit, right? So that little combo there, the 3D player, the 3D stage orientation, and the 3D light orientation allow you to kind of set the scene, right? And again, using the stage orientation, we can zoom back and forth. But when that becomes maybe more interesting, is to then to add another object. So I'm going to now go over here and I'm going to drag in the green circle, and I'm going to actually put that next to this and move these over a little bit. Okay, so, and you don't see it because I think it's inside. It's at the, everything's in the center, so it's inside of the cube. But if you go to the X translate of the green circle that you just brought in and set it to -1, now you see it is moved over. So the cube is at 0, 0, 0. It's right in the center of the world. And we took this green sphere and we shifted it left in the scene a little bit. And like we did before, we're going to turn the lighting on. And one thing that's probably, someone will say this immediately, because I turn the lighting on, you see this seam in the sphere. I don't know why that is. I don't know if it's like an issue with Cheetah 3D and the way that it creates spheres, but I've seen this seam in the spheres that I've exported from there. I don't know if, it shouldn't be there. I don't know quite why it's there, but I sort of was seeing it today and I didn't have time to do more about it. So maybe you can find better spheres than the one I'm getting out of Cheetah 3D, but there is this sort of issue of this little seam that you can see. But let's just ignore that for now. It's not important for what we're doing. And sort of to complete this scene in the classic way, I will bring in the blue triangle. And again, it's inside the square, but now we're going to click on X translate and say 1 and turn the lighting on. So now we've got the I guess I should do it in the other order. It should be square, circle, triangle, right? But anyway, it doesn't matter. We've got the circle, the square, and the triangle, and they're sort of in each other, right? They're actually inside of each other, intersecting each other. But like we said before, it sort of looks like you shoved that sphere into the square and it just like went inside of it, and we see how it's cut off, right? But the point here is that I wanted to make by bringing these in is, again, when we do the 3D stage orientation, we're now changing our viewpoint of the entire scene, right? Yeah? So they move as a group, right? We've changed the layout of them in relation to each other, but they move in a group. And I'm just going to play around with that. I'm going to take the Z translate on the cube here and move it up and closer to us, right? So now I've got that cube a little bit closer, and I'll take the X translate of the circle, move it away a little bit, and just for grins, I will go to the red square and I will translate the Y down a little bit. So just to make it a little bit more random, right? And again, we can do the same thing with the Z translate, right? And we can also do the rotations, and you see that the whole scene rotates, right? Because we're seeing it. The circle's rotating on its center right now because of how we have it set up, but the rest of the world rotates like so, right? So we're changing our viewpoint with the camera. Yeah? Okay, I'm going to set those back to 0, those rotations. Let's see. That's a good question. Shadows, we don't have shadow capability in Isadora. I mean, one thing that you have to think about here, you know, Isadora is not Blender. It is not Unreal Engine. It is not Unity. You know, if these softwares are specifically designed to make the most astonishing level of animations you can ever imagine, moving water and all this stuff that's really amazing. You'll never be able to do that in Isadora. It's not something that we're going to take on as a thing because there's other softwares that have done it way better than we would ever be able to do, even if we set out on a major effort. But what you can do in Isadora is you can render these models in a really simple way. And you can also then, you'll see in a little bit to remind you, use the new virtual stage feature to do those renderings, bring them in as a video feed, and use them for something else and manipulating as video effects, right? But, I don't know, it depends on what your usage is. But let's just go through the examples, and I'll just say that you know, if you're looking to animate a character like a human being that has expressions and can move and run, that's going to be pretty hard to do in Isadora, I think. I think that you can do a simpler level of animation, but that you can use that animation, you can leverage the video features of Isadora to do some pretty interesting things with them, right? And remember, everything is interactive, right? Just to give a quick example of that, I'm not going to get too far into that right this second, but let me just turn on the MacBook Pro microphone. So I've got a level, so you see the level going there. So now I've got a sound input, something I can manipulate with. If I get a sound level watcher, I should say that more carefully what I did in case there's a beginning user or two there. Live capture settings from the input menu. I chose the MacBook Pro microphone on the sound device and I said start live capture. That's what I did. If you do that, the sound level watcher will start moving. That's just reacting to the sound of my voice. So if I put that, for instance, in the Y scale of the red square, now you can see that I can adjust, I can actually make that thing bounce up. You could imagine perhaps making a whole VU meter where you take the frequencies of sound and use that to manipulate the size of the object, right? So, this is where maybe it gets interesting in Isadora, the fact that you have these manipulations that you can perform on these 3D objects. And that's just one example. But just for fun, I'll just go a little bit nuts here, do the X scale for this one, and do the Z scale for this one. And now you can see they're all vibrating as I speak, right? So I've got this weird manipulation now of these objects, right? Okay? That's what we can do in Isadora that maybe isn't so easy to do in some other softwares, and that's perhaps where these rather, in a way, simple models can become something quite interesting. I want to say that, by the way, though, if you download complex 3DS models that have texture maps and stuff, they really do look pretty great. I should have put on here, I have one of the space shuttle, being a space freak as I am, and it looks great. I mean, it has all the textures maps and, you know, everything looks really nice. It's very impressive. And what's also impressive is that because all of this data, all of the 3D data, all of the textures are uploaded to the graphics card, just like in a game, they render really fast, even if they're relatively complex. Again, don't expect to be rendering 4 billion polygons and get a smooth frame rate in Isadora. That's probably something we're not going to do as well as a thing like Unity or Unreal. But what you can do is what I just showed you. You can manipulate this stuff, and that's, again, where it gets interesting, yeah? And just a further example of that, let me turn off the bulging items here. I'm going to set all those scales that I just changed that are now not 100 anymore back to 100 so that these things are normal. Let's try another sound level watcher, and let's take it and use it in the Y rotation of the 3D light orientation. So now the volume of my voice is rotating the light around these objects, right? Now, that could be any sensor. Remember, we can do this with the mouse watcher too. I'm going to delete that. I'll get a mouse watcher, connect it to the Y rotation, and now as I move my mouse left and right, I can change the rotation of the light, yeah? And I'll even take the vertical position and go into this one. I've got it here. Let me make this so you can see what I've done. In fact, let me just start over. So I've got the horizontal position in the X rotation and the vertical position in the Y rotation. And now you can see that I can just gesture with the mouse and change that lighting in real time. Okay? All right. So that's the kind of thing that we can do in Isadora that maybe becomes interesting, is when you can start manipulating these things using real-time input, yeah? Okay. So, yeah, just adjusting that so it looks nice. Um, uh, can you tell us something about the texture map? Simply linking video or picture isn't giving us any result. Yes, that's because you have to have a 3D model that uses a texture map. These 3D models are just a bunch of points that define a shape. Yeah? They do not have a texture map that shows how to map an image onto those points. But if you grab the model called 3D model number 5, texture square.3ds, you'll see that it has the word Isadora in it. But let's go look in the Finder at that. You'll see here, here's the model, texture square.3ds, but here's a texture map, white 512.512.png. It's not actually white, but that's the texture map that goes with that 3D model. Yeah? So when there is a texture map associated with the model, then you can texture map it. So let me move this a little bit. I'm going to do the Y translate a little bit and the Z translate to make it a bit bigger. And I'll just make a movie player real quick and set the volume to 0 so you're not hearing the sound. Tell it to play movie number 1 and go into the texture map, and you'll see that indeed in that 3D model you are seeing the video being rendered because it has a texture map associated with it, right? There's no other way to do it because that texture map association instructs the program how to associate 2D points on the image to the 3D points on the object, yeah? So hopefully that answers that question, right? And you're going to see some nice examples of how to use that in a little bit, yeah? Okay? But anyway, that's cool. I wanted to add that in anyway, and I'm going to disconnect the movie player so it goes back to that image because I just wanted to get this situated, yeah, kind of in the square there a little bit, right? And because I just wanted to finish this off by adding a little wave generator, and I'm going to connect that to the Y rotation of this Isadora thing. So there it is spinning around too fast. So I'm going to change the wave shape to sawtooth, and I'm going to change the frequency to 0.1. Okay, so that's great. It's sitting there like a little sign on a restaurant spinning around, Isadora, yeah. But you'll notice that when it turns away from us, it's invisible, right? And the reason for that is when you're in a 3D situation, you're rendering this stuff, you always want to make it so what they call the back face is invisible to the camera, because when you're moving through a scene, you don't want to see the stuff that's like you're in or behind you. You only want to see the front-facing polygons, yeah? But for what we're doing with video, we often want to see the back of the thing, right? And so to do that, you go to the render back input and turn it on. And if you do that, then you'll see, yeah, that you can see both sides. The image, of course, is flipped when it's backwards, but that's what you would expect. And so now you can see both sides of the image. So now you can do that, right? And I want to go through some of the other inputs here to make sure. There's one really important one, and that's the depth test. I just want you to watch this. You don't have to make it, but I'm going to make an illustration here to really let you see how this works. I'm going to get 2 copies of that texture square and a 3D stage orientation, and I'm going to zoom that back. And I want to see here if I can create a little problem. Let's see, I have to Z-translate this a little tiny bit. Or maybe if I wrote, I don't even know if I'll be able to to make this work actually. Let's do the X rotation 0.05. Well, it's tricky to, let me try it with a movie real quick. Oh, well, that actually illustrates it right there. So everything is zero. Everything is zero. Oh no, no, it didn't actually do it. All right, I may not be able to make this error happen. It's a kind of a strange condition. I guess I just have to explain it so that you know what to watch out for. So in the 3D world, if two objects occupy the same position, they actually don't necessarily occupy the same position because there's actually there, look, as I'm zooming the camera back, you see it flashing? That's because there are slight rounding errors the inside of the GPU. As it gets further away, the amount of error gets greater, and sometimes it thinks the other one is in front. And so you make this move, zooming back and forth. And actually, wait, there was a great view of it right there. I saw a diagonal line. That's the real there. There. See that? So that's pretty weird, right? Why is that happening? Again, they are at exactly the same point, but there are these tiny rounding errors inside of the GPU, and it gets confused and it doesn't know what to do, right? So that's when you need to use this depth test input. The depth test is the thing that's comparing, is it in front or is it in back? And if you turn that off, now it's kind of like the normal projector actor. The order in which the actors are executed determine who's in front and who's in back of the thing, as well as the layer input. Yeah? So if you're trying to create a 3D world and have these intersections, then then you don't want to turn that off. You need that on. Otherwise, the intersections won't work, actually. But if you're having problems, and this happens often in the 3D particles actor, where they're kind of bumping into each other and making them vibrate, sort of like what you just saw, you can turn that depth test off, and now it will no longer pay attention to which one's in front or in back, but instead use the layer input and the blend mode to determine how it's going to be drawn. Okay, so that's the depth test input, which is, you know, really useful, especially you'll see in the 3D particles, but also sometimes in the 3D player. All right, let's go back here to our lovely Bauhaus restaurant, let's say, and with the Isadora Bauhaus restaurant. And I want to just hit a few other of these. I sort of hit on it a minute ago. Well, let's just go from the top and hit it real quick. The destination is the stage. The other possibility is the renderer, right? This is from the older days of Isadora, where you had this other object called a 3D renderer, and you could send the image to that, and it would turn it into video that you could then work with. In the future, I would strongly suggest that you work with virtual stages. I think it's going to offer a lot more flexibility in the future, but those features still exist so that old patches work. But above that is the actual stage. You see that I have a virtual stage in this patch, which we'll be using in a little bit, right? But going down here, the visible is just as it says, either it's on or it's off. If you want to hide the object for some reason, you just turn that off. The layer and the blend mode work as they do inside of the normal projector, right? And again, don't forget that the help is down here. So, and then there's a special mode that if it says here, if it's set to default, then the use alpha property will determine the blend mode. Or otherwise, this property forces the blend mode to the specified setting. So when it says default, you can actually assign alpha values to parts of a 3D model. That's possible, yeah? And if you say default, it will honor those and render it with those alphas intact. I didn't make an example of an alpha in the object like that, but just understand that that's what the blend mode does. But otherwise, you've got the normal blend modes, additive, transparent, and opaque, right? But if you set it to default, the object itself defines what part of itself is transparent. The lighting we've talked about, render back, depth test, the rotations and translates. And then the scale, it's pretty obvious. You have all scale, that's the whole object all at one time. Or you can, squeeze it or expand it along the x-axis, the y-axis, I'm sorry, this might be hard to see, the y-axis, or the z-axis, yeah? So you have that possibility of doing independent scaling. Um, if you would like, you can draw the object as a wireframe. Boy, that's pretty hard to see. I'll go full screen there. I don't know if you can see that. Let's do it with the green object. That'll be clearer. So here's the green square. Wireframe. There you see the wireframe rendering. Or the other choice that you have is points. So it just becomes the points of the polygon. So that's kind of retro looking and fun in a certain way. So that's just there for you. The texture map input, as I explained, if the object has a texture map associated with it, then if you feed video in there, it will be wrapped around that texture. Also take note, if there are more than one texture associated with the model, which is possible, only the first one is going to be used for that. That's important to understand. If you're going to wrap video around an object and you want to use it in Isadora, it needs to be the first texture that you've defined, and that way you'll know that it's going to get mapped, right? Again, when I've done this for performances and things I've worked on, I typically work with quite simple 3D models that I'm using for different purposes. And you know, if you're getting more complex than that and you have 20 texture maps, you're just not going to be able to change the image on those other 19, just the first one, yeah? The texture map scale should, let's see, I think Bone Map was saying that it didn't work and then he said it did work. But yes, it scales the texture map from 0, 0, and thus changes the size of the texture map, right? So that allows you to sort of scale the image inside of there. And then this use alpha, which, like I said, I didn't actually make a model that has these alpha definitions inside of the object itself, so I can't really demo that. But that's what the use alpha is. If you turn that on, then it's going to respect those settings inside of the model itself. Okay? All right. Wow, we're already an hour in. It's like there's a lot to cover here. I'll be able to go a little bit faster. We can also just sort of see the results of my examples and see how it goes. But I really wanted to give the time to this 3D player and the 3D stage orientation and the 3D light orientation, because once you start to get the principle of this, when you start working, if you haven't worked with the 3D model particles actor or the 3D model particles or the 3D ropes, there's going to be a lot of stuff that is very familiar because you understand this. So I'm hoping that that will take you along. And I see a couple questions. Let me take a moment for that. Yes, a 3D model. The question is, so is a 3D model in Isadora can be more than one geometric object? Absolutely. I imported a thing that was like a kitchen and it had a table and chairs and like flowers on the table and all this stuff in it, and that totally rendered, right? The space shuttle thing that I mentioned, I wish I had that model for you, but the space shuttle that I mentioned is fantastic, you know, and it has the doors are open and there's some like scientific experiment inside of the bay and everything. So these are very complicated model with lots and lots of polygons. And so it's very possible you can have many objects inside of that one 3ds file. No, and the other question, does the 3D light have an X, Y, Z position? Let's put that on the feature list. I think that that's something. Maybe we should have a discussion about how to make use of this in the forum, because thinking about how we would I can imagine doing camera moves where you have a camera that really flies around the scene, but how would we set that up? I'd like to have a discussion about that. But right now, no, the 3D light does not have a position. It's always rotating around the center, basically, yeah? Okay. All right, so, so here we go. I'm going to go now. I'm just going to let you see the sort of finished version of this. It's not much different. It's just that I need to turn the render back on. Oh, it is on. So you see that I've got the Isadora part of it moving back and forth through the circle using this wave generator here. Yeah, so like so. Okay, that's where I got to when I was preparing the lesson. But let's look next. Go into the new scene here called Screen Pre-Visualization. I use this to be able to prepare for a show. This wasn't in the show, but I had 6 screens and I was going to project video on all 6 of those screens, and I needed to be able to sort of see what that was going to look like before, because it took a long time to build this stage. I had to wait a couple of weeks before it was ready and the whole stage was built, right? So if you go over here and drag in the one called Swarm Screens, And again, it's at the center of the world, so we need a 3D stage orientation actor. And we're going to back up, and probably you're going to have to rotate it a little bit. Well, first of all, let's turn the render back on. Now you can see it. So if you turn the render back on and zoom back to about 30, and I would also suggest you take the Y translate and drag it down. What you'll see there is that there are 6 screens, each with a number, right? And I'm going to spin it using the 3D stage orientation so you can see all of the different screens, right? So there's 6 screens here, and this actually answers the question that Clem asked a minute ago. Can you have more than one geometric object in a 3DS file? Well, there's 6 geometric objects here. There are 6 rectangular planes, right? But the trick here, and this is the fun, tricky part of it, I'm going to show you that 3D model in here. That's in this swarm scene. Let's look at the texture map that is associated with that. Can you see here that what I did was I have an 1800 by 700 pixel image because that was my output resolution to these screens. They were using Pico projectors. They were not using great projectors, so 700 pixels was plenty tall enough, right? But so it's 18 by 700, and you see that I've got these independent images. So when I prepared my media, the different screens were rendered such that if I wanted to have something particularly on screen 4, I would put it in this area. So there is one texture map that I have assigned to the 6 objects, except I kind of moved it over in such a way that you only see one of those on each of the 6 rectangles. I hope that sort of makes sense. It's a little confusing, but basically I think if you just look at the image now, we go back to Isadora. Let me just put a wave generator on that and rotate it for a second so you can really see it. Okay. So there, you see that you've got these 6 screens. There's that one texture map. The objects are not even connected, but I assigned the texture map in such a way that each one of the screens has 1/6 of the image. I hope that makes sense, because now what I can easily do, again, just using one of these, it's not, I don't really need to have a 360 movie for this. I'm just doing it because we have those clips now. If you take that, I set this to movie 1, volume to 0 again, and go down and put that into the texture map input. Now you can see that the movie, which is, by the way, not 1800 by 700. My material that I was using for the show was 1800 by 700, is now chopped and distributed on the 6 different screens, right? So there, you're able to take one image and turn it into a 3D world, right? And assign it to these different screens. And again, I did this simply so that I could see what this was maybe going to look like once the stage was actually built. And just to finish that off, I have another handy 3D model here I use all the time, this 3D checkerboard floor. If I drag that in, it puts a checkerboard at 0, right? It's centered in the 0, and it's like, it goes out a ways, right? So now you kind of have this floor that's right underneath the screens, and you can see there, let me slow that down a little bit. You can see that the floor is rotating as if you were walking around the scene, right? So that 3D checkerboard is a really handy model. I use it all the time when I'm trying to sort of figure out what's going on and see what's happening, right? So I just wanted you to see that, because using, if you have a 3D modeling program like Cheetah 3D, again, I find that one so easy. You can start chopping your texture maps and putting them into different objects. I did another one that I don't have with me, but that was a bunch of picture frames. It looked like a bunch of picture frames, and it was the one texture map, but just by chopping it into pieces and scaling it a little bit, I had these separate areas that I could feed into, and I could go into those different texture maps individually by putting it in the right place in the original image. Again, remembering that the source image is this, right? It's the single image with the 6 items. How's that feel? Let me take a breather here to ask a question, see if that makes sense. if there's any questions about this technique of using this. Again, I did it as a pre-visualization, but you could, of course, use this in any kind of way you wanted. So let me see if anybody has anything to say about that before we go on to the next scene. I'll just show you, I think the final version was pretty much exactly what I just came up with. So maybe I zoomed it a little bit different, right? Oh, by the way, if I put myself in the center, that was the other thing that was nice about the pre-visualization. I could almost imagine that I was an audience member because the audience was allowed in the center of these 6 screens during the performance. And I could get a sense of what it was going to look like for them if they were inside of it, yeah? Okay. All right. I think that nobody has any questions about that one, so hopefully you get the idea. And try this, though. Try doing some experiments about taking individual objects and mapping parts of a texture map, a single texture map, into that, and then you'll be able to try this technique of routing video to different objects in the 3D world. Yeah? Okay. Now we're coming to something that I just did totally for fun, and it was a kind of a weird track that I got on. But I thought it would be good to show some ways to, I thought I'd make a little game, sort of, just to see what I could do with Isadora in terms of this 3D world stuff, yeah? So the finished game is over there. I ask you, if you hang on, to not click on it yet, because it sort of give everything away. But what I wanted to start with, I thought, well, I need a scene. I need to be in a world, and I didn't want to go. I was looking at some 3D models I suggested in my forum post, Turbo Squid or CG Trader. Those are great, but like even the royalty-free stuff on Turbo Squid, it wasn't clear to me that I could put that in my download legally. The contract is like 4, 5, 6 pages long. So because of that, I sort of hesitated, and I'm like, well, what am I going to do? I want to have a complicated scene. So this is my solution. I'm going to go over here. There's one called M-Tree. Okay? I'm just going to drag that in. Again, the 3D stage orientation immediately. And we'll drag it back, and you see there's a tree, right? Okay? But here's what I'm going to do. I'm going to get a random actor, 2 of them actually. So everyone do this. You've got the 3D player playing the tree, and I'm going to get the random actor, and I'm going to connect that to the X translate and the Y, I'm sorry, not the Y, excuse me, the Z translate. So these random numbers are going to move the object this way and this way, not up and down. Don't hook up Y, and it should be 0 still. And then we're going to add an enter scene trigger, and then I just hot linked that, and we hot link that, and now every time I enter the scene, it's going to pick a random number for where this tree is going to be. So if I leave and come back, we don't even see it because who knows where it is. It's maybe behind us even, right? But don't worry about that yet, that we don't see it. It's right now, it's using the automatic scaling features of Isadora. Let's click on X translate. Ah, I see, it's the scale min is -100, scale max is 100. So the output of the random number actor, which is 0 to 100, gets scaled to -100 to +100. I need everyone to click on X translate and set that scale min to -25 and the scale max to 25. Same thing for the Z translate. Okay? So now you've limited that scaling so it won't go so far away from the center. Let's leave the scene and come back, or you can just trigger this and see, oh, there, I got it. So if you click that enough times, you'll see the tree appear sometimes because it'll be in front of the camera, right? So why am I doing this? Because I want a forest. So what I decided to do was I made a user actor. So I just added a user actor, empty right now. I'm going to take this whole little deal, these 4 actors, and cut them. Go and double click on this user actor and paste. Hit save and update all after I've pasted. So I've got this user actor. Oh, there's our tree, right? You see the tree there. And now I'm just going to duplicate that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 trees, 20 trees, 30 trees, 40 trees, right? And so now you can see, if you zoom your 3D stage orientation, we've kind of got a forest. Yeah? Oh, I made a mistake. I need to turn the lighting on. So if you did that with me, I'll let you catch up. You should try and work with me on this because I'm going to go through this whole patch. Double click the user actor, go to where it says lighting in the 3D player and turn that on, and then say, click the close box and say save and update all. And now the lighting is turned on. It looks a little bit nicer and brighter too. Okay? And then because we want to be, it looks a little up because 0 is right here at our eyeballs. We want to lower that down. So I'm going to say set the Y translate to minus 1.5 so that now it really looks like we're in the trees, right? So we just lower that scene down, lower the camera down, or actually we'll raise the camera. Anyway, we do it so that we can see those, right? So now we've got all these trees, right? And I want to add, it's not really so nice. I should have had a forest floor, but I'm just going to go ahead to give that little reference point that it adds. I'm going to add the checkerboard floor there, okay? So now you can see that we can see this, and we can also, well, what I want to set up is we want a way to move through the scene, right? So we're just going to use the mouse watcher, super simple. So go ahead and add a mouse watcher. And what you're going to do is you're going to connect the, let's see, how did I do this? The vertical position is going to go to the Z translate. And you're going to set that Z translate. You need to click on the word Z translate and set it to minus 25 to plus 25. Did you notice that those numbers match the numbers that we used for the limit of the random number input to the trees? In other words, our field, our scene, the forest, has a range of plus and minus 25 in the X and Z dimensions. That's kind of our world, right? That's how big it is. So you click on Z translate, set scale min to minus 25 and scale max to 25. And now, if you move your mouse up and down, you can kind of run through the forest here, right? Okay? And then, if we want to rotate this, we can simply take the horizontal position and go into the Y rotation input. And for that, that does 2 revolutions. That's its normal setting. We're going to change that so that it does scale min of 0, means it's going to rotate 1 full revolution as you move the mouse left and right on the stage. And so now you'll see it's totally like a shooter-up game, right? You can just move the mouse and navigate through this 3D world. Yeah? So we have, using this feature, and by the way, it's sort of interesting, every time you leave the scene and come back, the trees are in a different place, right? Because the random number fires every time you enter the scene, and the trees change their location, so it's never going to be the same twice, the layout of this forest that we've made, yeah? Okay, so we've got this world, and then the next part I did is, frankly, I kind of went a little bit bonkers, so I'm just going to show it to you and explain it. So let's go, everyone go to the game scene finished, and now you need to press letter A. Everyone try. All right, so I made a thing that shoots a ray gun and got a great pew pew like sound effect, right? But I have to admit that that to actually make this work was kind of complicated, and I'm not sure if it's useful. I'm going to go through it. I'm going to explain it, but there's some math happening here, so if you don't dig math, this is not going to be so much fun. But you can just sit back and just kind of like absorb it, just feel the feeling, right? All right, because the trick of this was I wanted to have the gun or whatever it is, the shooting off this 3D particle, um, always shoot from like your viewpoint. That's kind of how it would be in a shoot 'em up game, right? So how does one do that? Well, there were a few things I had to do in this patch. Let's look at them. First of all, look at the mouse watcher. It's what we just did in terms of traveling through the scene. But notice that I also hooked this up to the Y rotation of the light. Why would I do that? Well, I'm going to disconnect that and set the light to 0. And you'll see, well, these trees actually don't show it so perfectly. Yeah, the lighting's on. Oh, let me do it. Okay, I've got that disconnected. What the problem was that from some angles, my little particle was not very visible. And so anyway, what I did was I hooked that up so that the light is rotating along with the camera, basically, right? And so that way, and it's actually offset by some degrees. You'll notice that I changed the scale min and scale max. That was just to make it look nice because I didn't want to have it coming right out, the light coming right out of my eyeballs, but a little bit off to the side. So I changed the scaling from minus 200 to plus 160, which in the end is 360 degrees of rotation. So anyway, that was one different thing I did was I was adjusting the light so it was one thing to think about. If you want to adjust the light so it's always behind the eyes of the viewer or always coming from a second angle, then as you rotate the 3D stage orientation, rotate the lights too, right? And keep them in sync. Or in opposition really, so that as you change movement, the lights compensate so they're always coming from behind you. But the real trick here was making that bullet, or whatever it is, this little polygon. I don't really like bullets, but you know, let's say this magic football fly from your viewpoint, yeah? And the basic idea was we needed to use the mouse watcher. That's how we're deciding which way we're looking, right? We needed to use the mouse watcher to do this. So the first step was to use a calculator actor to multiply the mouse watcher value from 0 to 100 by 3.6, because then 0 to 100 becomes 0 to 360. And then to really make this work, I did this in the other guru session, right? Last week. We need to there's this thing going on. I think I might need to make an actor for this where we have to exchange the rotation order. I'm not going to cover that again. Hopefully some of you are here. That's in guru session number 3. But this notion that Isadora has an order of rotation, it's XYZ, and sometimes you need to do the rotation in a different order. This actor does that because what you really needed to do, and this is where the math comes in, if you want to know, if you have an angle and you want to turn that into an XY vector, like how much X and how much Y, you have to use a sine and cosine function. So that's the gory details. And I'm not going to actually explain everything about the math in this. It works, let's just say that, because I'm not even sure I can explain it that well. But the bottom line is, coming out of that rotation calculator are the values from -1 to +1 for X and -1 to +1 for Y, depending on the angle of where we're looking. Because those values are then used to control one, and this is a 3D model particles, right? So it is a particle system that generates a particle and sends it off into a direction if you tell it to. So we want the particle to come from where we are, right? And using that math over there and these extra calculator actors, I was able to get it so that this X and Z point is where you are in the space. So now, as we move around, the origin of the 3D particles actor is traveling with us. It's always sort of in the center of our chest as we walk around the forest, right? And then this is where that other calculator came in, and it actually, I have to take back what I said a minute ago. It actually did not have to do with the different rotation order. It's just that we needed to take a single degree from 0 to 360 and convert it into its x and y components. Think about it. If this is an angle of 15 degrees, the x is this big and the y is this big, right? This is like going back to trigonometry in high school or whatever, right? And that's what you're able to calculate, like what is this much and what is this much of the angle. That's what you can find out. And so using those numbers, I set the x and y, z velocity. So the particle's here, and it's got this xz velocity so that no matter where I'm looking, it's adjusting that so that it goes straight forward from where I am, right? So it's the combination of the x and z position and the x and z velocity so that when I generate the particle, it goes off in front of you. But the beauty of it is, as you've all seen by now, all those particles persist and you sort of still see them. Just for fun, I'm going to change, the velocity of the particles is controlled by these two -50s here. So I just downloaded, no, it's not my voice. I found it on YouTube somewhere. All right. I'm going to set these -50s to -10 so that we can we can chase the particles if we want. Hold on, let me get to the other side of the forest. 1 second. Here. Okay. So now I can go chase my own bullet, not my bullets, my magic footballs. All right? So, and obviously there's a sound player, and the sound player is connected to letter A2 so that every time you press it, you get a sound effect that goes with it. All right? So, I really, explaining that math, I'm not really sure that I can really, if you're not into math, it's definitely not going to be easy to do. Even if you're into math, I mean, I really had to think about this. I ended up spending too much time on this particular thing. But at least it works, and maybe that's something that you can weave into another patch. Everything I'm making here, please use it if it's useful, that's for sure, right? All right, and so I'm gonna just ask if there's any more questions. We have one last thing. So if you've got some final questions, we're coming to the end here. I'll just go into, let's just jump into the scene called Logo Guru. That's the little quick logo that I made for the announcement today of this. And the thing that's important about that, we've seen everything that's going on here. The 3D player is playing a 3D model that is that text. Yeah? And let me just make that super clear. I'll just drag that in. Where is it? Oh yeah, Guru logo, sorry. 3D stage orientation. So if I zoom that back there and we turn the lighting on, right? The lighting's kind of weird here, 3D light orientation, and put a wave generator and assign a sawtooth 0.1. Always want to use the sawtooth for the rotations. That's a good trick because then it always rotates around. So I put that in the Y rotation of the lights. Now it's like the light is rotating around, and there's this flip, right, at a certain point. I'm going to set it to -180 and +180, see if that does anything. But anyway, the lighting's rotating around. We can do it in 2 dimensions too. Here, I'll make a different one for the X rotation of the lights. So very dramatic lighting effects on this 3D model of this text, right? Okay, so that's the 3D model of the text. But if you go to this logo, so I'm actually doing that. I'm actually spinning the light orientation, but I'm also spinning the image itself. I'm doing the Z rotation, which is this, right? And I'm Z translating it like this. So we've got it spinning this way, but also moving towards us using this first wave generator here, right? That's how we get the movement. But then what I wanted to have some little trails or something to make it a little bit more cool. So this is where you'll notice that this one, the target for the 3D the stage orientation, the light orientation, and the 3D player is the virtual stage. If you click on those, you'll see They're all set to the virtual stage. And if I open up the stage setup editor, which by the way is here in the output menu, I open this up, you see that this one, this pre-visualization, does not have the trails. That's just the 3D model. And that's being rendered on the virtual stage. I also have the preview down here disabled because I didn't want to see a preview stage for this. I just need it as a channel where I'm going to feed these 3D renderings. So I'm going to close that now, and then I'm using the Get Stage Image actor to pull the image from the virtual stage into a projector, a 2D projector, not 3D. At this point, you're pulling the rendered image back, and it's now 2D. And all that stuff of like colliding and overlapping and things being in front, that's done at this point because it's been rendered into that 2D space, right? So on one of them, if I turn off this projector, here's the image just over the background without any of the motion blur. I've just disabled that. So that's what it looks like without any effects. And but if I turn the motion blur on, I'm rendering the original 3D model, but I'm also rendering, sorry, turn the bypass off. If I turn the active on in this projector and turn the 3D motion blur back on, now I'm rendering the model and that blur, which just gives it a little bit, I mean, it's nothing amazing, but it kind of gives it a little bit more life, right? But mostly I did that because I wanted you to see. That was what I needed to do today. I wanted to make something a little more spiffy, and that's what I did, was I used the virtual stage to render that 3D model. Again, I made that text in Cheetah 3D just like in 2 seconds flat, super easy to do. And then I just added this picture, the background that you see, that if I get rid of the picture, you just see this, yeah? So there's a question, what are the artifacts that come with the MB, motion blur? I don't know, I mean, motion blur, yeah, there could be some stuff in the background image too, you know, you sort of get some, with these gradations, you can get banding. I'm not really sure what artifacts you mean. I think you need, might need to explain to me a little bit better what you mean, Fubi, by those background images. I'll try to answer your question. I'll come back to it though, because I want to sort of finish off since we've been at it for an hour and a half. Last topic, this is something that I taught at the Werkstatt, and that actually was Graham Thorne who first turned me on to this idea, and it's a really simple thing, but it's pretty cool. So if you all just click on the last image, and the reason that I had you download those 360-degree videos is because I've created a scene here that where you use one of the 3D actors to be able to render a 360-degree video and to be able to look wherever you want inside of the video, okay? So, I'll come back to your question about these things in the image in a minute, Fubi. But anyway, if you just go into the scene and you move the mouse left and right, moves the image left and right, and then up and down allows you to look up and look down, yeah? And before, when I was talking about this rotations issue, like that some things expect to be rotated in a certain order that is not the same as Isadora, I did that in Guru session number 3. This is the same actor that I provided in that tutorial, and that's the one that I feel like I probably need to turn into a dedicated Isadora actor instead of JavaScript. But suffice to say, to get this to work right, I had to perform that change in the rotation order, yeah? And, but the way this works is, if you'll notice, there's no, the 3D stage orientation is set to 0, right? I have one because I've changed the field of view. I'll explain that in a minute. But the camera is at the center, and the sphere that we're in, we're looking out to the edge of the sphere. And then this has a texture map. Now watch what happens. If I delete the connection to the movie, this was like, I don't know where this came from actually. It's like the inside of someone's house. I really don't know what this is, like a kid's playroom. That's the actual texture that is associated with this 3D model. But of course we're replacing that with the 360-degree movie that we imported, right? And again, this should be it doesn't matter which one you use. I can also change this to be movie number 2, and now we're at the seashore looking there, right? So there's really simple though. You just like once you have the sphere, you just have to feed in this X, Y, and Z rotation, and you can actually look anywhere in the image just using the mouse, right? I when I demonstrated this before, I did it with the program Gyros. That's GY. Let me just type it actually in the chat so you can all see it. This is an iOS application that takes all the rotation information out of an iPad or iPhone, and you can send it into Isadora using Open Sound Control. And it was a really beautiful interface because I was just able to take the phone and I would do like this, and I could totally spin this cube and look around, and it was really magical. I also added, just for fun here, let's go back to movie number 1 if you switched it. You notice that there's a measure color actor down here. And what that's doing is that I actually, in the one demo that I did, I took the output of that measure color actor, and I'm going to make this even tinier so that maybe it changes a little bit. It's not really changing very much. Maybe bigger. Yeah, it's changing a little bit. Anyway, this isn't the best video for doing that with, but basically it was analyzing the color of the video, and that color there was being sent out to an RGB light, and it allowed you to have the lighting in the space match the center of what was in the video. That was actually a little technique that I used. But that's really all I had to show here. I just wanted to show this because it was really a nice thing, and again, it came from Graham, who first turned me on to this. And you can take this and use it with any 3D 360-degree video, and you could just have to use this patch and you'll be able to do those rotations. One final little thing that I did, I have this user actor here that I make called tent. It's like what we call a tent function. There's a center, a width, and as you get into that, if you imagine the tent, the closer you are to the top of the tent in terms of the values here, you get a higher number out of it. And if you listen closely, I'll turn this up for a second, I've got it so that you hear the waterfall all the time, but when you look at it, it becomes louder. So it kind of gives this illusion that you can even experience the aural sensation of being in this space. Let me just full screen it for fun. Okay? So that tent function, it's the waterfall center there happens to be at angle 0. So the center of the tent is at 0, the width is 90 degrees, and then it has an out minimum and an out maximum. I don't want the volume ever to go to 0, so I set the minimum to 25, and I set the out max to 100, okay? All right. Question, does the volume in the movie player overrule the mute? I don't know. Shouldn't, but let's find out. Not for me. I'm changing the volume there and I don't hear any. Oh, I'm sorry, I hit pause. Yes, it did overrule the mute. I think we know that's a bug and I think we fixed it. Lucas, can you verify that we've taken care of that in the beta? I think that's taken care of. I think that's not the behavior that we would like it to have. It should stay muted even if you change the volume, right? Okay? All right. That's basically what I had. Oh, let's go back to Fubi's question to see if I can see what he means by these artifacts real quick here. Fubi, I think that maybe what you're seeing, I've got the motion blur turned up to such a low level that it's leaving a lot of information there. If I turn the decay amount up, I bet those... It's definitely in the motion blur is hanging on to some of the image. That's what I think you're seeing, Fubi. I'll take a closer look at that, but definitely I can see clearly that if I turn the motion blur off, if I bypass it, that artifact that you're talking about is not there anymore. So it's something going on with the motion blur. I don't know if it's somehow, yeah, I don't have an explanation for that right now. Yeah, I see what you're saying, Lucas, that it is that's where the motion blur has never been. But that means the motion blur is never getting back down to zero, which doesn't make a lot of sense to me. So, all right. I'm going to speak for just a minute more. Your final pressing questions will come out. I should talk to you like this since it's April Fool's Day for the final bit. So if you have anything else that you're curious about, let me know. I hope that that was an interesting session for you. Really, I just wanted to get to the basics, the real core basics of the 3D stuff and talk about it at a really base level. I think there's a lot more that you can do that can be quite amazing with this, and you can import very complex scenes. You can import models with multiple objects in them. There's a lot that's possible, but I just wanted to get the core really covered so that you would feel confident when you're getting into actors like the 3D particles and the 3D model particles and the ropes and stuff like that. So that was my goal today. And, oh, field of view, thank you. Oh, very good. Someone asked me about the field of view. Now I got to get serious again. Hold on. All right, so the field of view is what's the angle of view of the camera, right? Normally it's 40, but you can see that as I increase or decrease this, how much I can see changes. I set it to 70 for this particular example because it just felt a bit more natural in terms of like what I was seeing in terms of a view. But let's go to the game scene here, right? Watch what happens if I set it to 20 or to 70 or to 100. I mean, it gets distorted. The corners are distorted because now it's almost like a fish angle lens, right? But it's basically the field of view. It's how wide the angle of is, right? So it's simulating that same thing that we know from lenses. So that's what it does, right? Okay, what's the field of view? I think that's it. So, all right, that was a long one. You guys are so awesome for sticking with me and through all of that. So I hope it was helpful. As is our custom here, we're leaving this on for this chat going for 10 minutes. So if you want to say goodbyes or something more to our comrades in the chat, you can do so. But for me, I'm going to sign off for now, and I will see you for the next tutorial. On Friday, we're going to do user actors, but that's going to be for beginning and novice users, so we can take them through the ideas of using a user actor. Thank you so much for coming, and I hope that you're all staying well and safe, and I hope to see you on Friday. All right, have a great evening, or afternoon, or morning. Bye.